Next for lesson 2, we'll look at phase angle and how AC reacts with resistors in a circuit. The phase angle is the angular distance between the same points on two different waveforms at the same frequency, blah, 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 etc., etc. Basically, we're talking about here. Phase angle between V of A and V of B is just 90 degrees. Oh, there we go. Wasn't in preset mode. There we go. Highlighter. Okay. The phase angle between those two is 90 degrees. You hear me talk about that a lot sometimes. You know, we use phasors or phase angles to represent the differences between voltage and current, or between voltages. The phasor is the entire cycle. Now, we've talked about time factor and frequency and phase. You know, theta is your angle. That's what they're using. Yeah, phase angle divided by 63 is 1 over F. I won't test you on this, but that's another useless fact you need to have in your mind. Now here's where it gets interesting. Here's an RC circuit, or not an RC circuit, a resistor circuit in AC. Just like before, we still calculate our sums. So that's 30 ohms right there. 120 volts divided by 30 ohms is going to give me a current of 4 amps. I've still got to get a voltage across here and across here. Okay, we still have to have our voltages across here. I got interrupted, so if I repeated something, that's the way it works. From there to there, which means now that I know that my current, my ohms, 4 amps, 10, it's going to be my 40 volts. Come on. 40 volts there, 80 volts there, 40 and 80 is 120. So all that plays out, still stays the same. The technique's still the same. Same thing with the parallel circuit. 120 volts is all the way across here. So 120 divided by 10 is 12 amps. 120 divided by 20 ohms is 6 amps. And that's going to give me a total of 8 amps. We did all of this all day long with DC circuits. Nothing is changing with this, with resistors, in terms of DC circuits and AC. The same thing here. We get our equivalent here. Since that's 20 ohms, that's going to be 10 ohms. So I now have an equivalent of 10 ohms here. Since I've got 10 ohms here, 120 divided by, and in parallel with that 20, that's 30, or in series with that 30, that gives me, my current is 4 amps for this area. Amps, which means my voltage there is 80. 120 minus 80 gives me my 40 volts. And since they're the same current, same voltage there, 40 divided by 20 gives me 2. 40 divided by 20 gives me 2. Boom, boom. There we go. Same thing. All this still happens, still applies. Yeah, still works the same way. If you talk about getting into power and all that, it also applies the same. Read through the rest of this. The rest of this one. I'm not going to go over it because we're not going to go over it in class, but it's good knowledge to have. Non-sinusoidal waves. Square waves we use a lot in digital circuits. It's on off. It's on or off. Sawtooth, pulse wave is also used in digital. The differences between a square wave. I get the pick pen. I didn't mean to. Square wave. The on and off duty cycles are going to be the same. Whereas in a pulse, the information is actually encoded in the difference between the two. And the difference between this length and this length. So this could either represent a 1 or a 3, depending on how you're looking at it. Because one size versus that one. We'll get more into that as we won't get into any of that in our class for this thing from here, but it will get into it for the other one from there. Okay? If you have any questions, give me a call. Do the homework that's assigned for this. I believe I assigned 4 or 5. Just get back into the practice and doing this again. Okay? Thank you very much. Have a good day. Bye now.